So we have other forms, other indeterminate forms. The first form will be something like this. We are looking at the limit as x approaches a of a product f times g such that it's either 0 times infinity or infinity times 0. That's another indeterminate form. And the remedy, what we want to do, we're going to rewrite as rational function. So we're going to rewrite f times g as a rational as f divided by 1 over g, or g divided by 1 over f. The advantage now, instead of dealing with the product, where let's say f equals 0 and g equals infinity, then we have 0 divided by 1 over infinity, which is 0. So we end up having 0 over 0, or we end up having infinity over infinity. Okay? So here's the first example to show you. Let's try to evaluate the limit as x approaches 0 plus. This is a one-sided limit of the product x times natural log of x. And because natural log of x is not defined for x, for negative values of x, or x equals 0, it's defined only for positive values of x, when we have to write the limit as a one-sided limit, 0 plus. So how are we going to evaluate that? First of all, notice that we are looking at the limit of x when x goes to 0. So we have 0, and the natural log of 0 is negative infinity. So it's this type that we put in the box, and we need to rewrite it. So rewrite, and we say that the limit, instead of x times natural log of x, we're going to rewrite x as 1 over x. So we'll end up having the natural log of x divided by 1 over x. Notice that it's the same as x times natural log of x as we divide by a fraction. And the other way, the next step is to write it as x to the negative 1. Okay, and now notice that we have infinity over infinity. So this is qualified for L'Hopital. Matter of fact, we have negative infinity over positive infinity. Nevertheless, it's qualified for L'Hopital, and therefore we take derivatives. The derivative of natural log of x is 1 over x. And the derivative of x to negative 1 is negative 1 x to negative 2. And if we write it as the limit as x approaches 0 plus 1 over x divided by negative 1 over x squared, it's simplified as 1 over x times x squared times negative x squared as we multiply by the reciprocal, or we end up the limit of negative x, and then we do direct substitution with 0, and we end up 0. That's it. So this is an example where you deal with the product 0 times infinity. You rewrite it as the rational function. Notice that here we have a rational function, and then of the type infinity over infinity, and we can apply L'Hopital. Okay, another L'Hopital form is infinity minus infinity or infinity plus infinity. So we're looking at the limit as x approaches a of f plus minus g such that on the face of it we have infinity plus minus infinity. And this is today's last group. So here comes an example using a little trick. We look at the limit as x approaches pi over 2 of the secant of x minus the tangent of x. First of all, let's see what happened. The secant is one of the cosine. Cosine of pi over 2 is 0, so the secant is 1 over 0, so it's infinity. The tangent is sine over cosine. Again, we have cosine of pi over 2 in the denominator, or 0 in the denominator. So we are looking at 0, at infinity minus infinity. Okay, so, but I need to make it, we need to do something so this particular limit is qualified for L'Hopital. So I'm going to write, instead of secant, I'm going to write 1 over cosine. So it will be the limit as x goes to pi over 2 of 1 over cosine, and the sine will be, of course, sine over cosine. So we have a common denominator here, and therefore I can write it as the limit as x goes to pi over 2 of 1 minus sine x divided by cosine x. And let's see, are we qualified for L'Hopital here? Sine of pi over 2 is 1, so we have 0 on top, as well as cosine of pi over 2 is 0 at the bottom. So we are qualified for L'Hopital. Therefore, we take the derivative of this, the ratio of the derivatives. So the derivative of 1 minus sine x is negative cosine x. And the derivative of cosine x is negative sine x. And let's see what happened here. The denominator is negative 1 because sine of pi over 2 is negative 1. Okay, so we have negative 1 here, and the derivative, the negative cosine pi over 2 is 0. So the result is 0. Folks, that's it. I'm done for the day, I think.